Hey there, we're getting into protein synthesis part 2, and this is translation. So we've just produced the mature messenger RNA in the last video. Now we're going to translate it on the ribosome into the actual amino acid polypeptide that can fold into the functional protein. So this occurs in the cytoplasm, typically on the endoplasmic reticulum, the rough endoplasmic reticulum. So we're going to look at the steps of translation. And if you look at figure 3.16, you're going to see step 2 and step 3, where the mRNA leaves the nucleus, and then tRNA brings with it amino acids that are producing that specific protein. So here we produced the messenger RNA in transcription. We then had to modify that messenger RNA to make it mature. It leaves the nucleus, enters the cytoplasm. It's going to then attach to ribosomes on the rough ER or free floating in the cytoplasm. The ribosome has two subunits, a large and a small subunit, that attaches and starts at a region of the mRNA that codes for the start code, which is AUG. So you don't actually see that on here, but that's okay. The idea is there. You can, so. Once the ribosome has attached, then transfer RNA comes in with a region called the anticodon that can bind to the messenger RNA, and it carries the amino acid coded for in the messenger RNA. And that's how we produce the polypeptide or the protein. So we're going to go through this process, and this is just showing everything I just talked about a little bit closer up so you can kind of see what's going on. And I've already talked about this as well. So I didn't talk about the tRNA once it releases the amino acid. It then can be released from the ribosome and go off and pick up another amino acid. So I did not mention that, but that's going to occur. So here, how this tRNA is attached here, it carries this amino acid. Once the amino acid is released and attaches, then this tRNA can leave and go pick up another amino acid. So they're not reused continuously. And you can see that right here, okay? So this is my OpenStax textbook that's showing what's going on. So DNA carries that information. You have that template strand here, the actual coding strand here. This is going to be identical to this coding strand, but wherever you have T's, you have U's down here. So you use this. T is complementary to A is complementary to U, C is complementary to G, but it's identical to this coding strand. AUG then codes for an amino acid called methionine. CCG codes for an amino acid called proline. And so that's how this is read. Oh, I don't know what I just did. That's not what I wanted to do. There we go. So during translation, mRNA is read 3 nucleotides at a time, and the proper amino acid is going to come in. And so here, the amino acid that is always going to start the translation process is methionine. So this is, again, my translation showing what's going on. So these pink, I don't know what they are really. They're like little arrows with big boxes. These are my tRNAs. The yellow thing here, that's my ribosomal RNA. And then messenger RNA is this molecule here. So the tRNA that carries methionine, which is a which is an amino acid, has an anticodon that will bind. So U binds to A binds to U, C binds to G. The the tRNA that carries glycine has this anticodon that will bind to this codon in the messenger RNA. They both bind, and then you're going to have a bond form between the methionine and the glycine. This bond is called a peptide bond. And so methionine and glycine are going to be bound together, and then these messenger or these transfer RNAs are going to be able to leave and go pick up new amino acids. So here we have that bond. The first transfer RNA leaves, the ribosome moves, and another amino acid can come in, and then eventually another amino acid will come in, and then it's going to move again. And you can just see how it goes all the way along until we hit a stop code. So remember, in that codon table, there were 61 codes and then 3 that coded for stop. This is a stop code that stops translation. Once that occurs, the ribosome is free to be used again. The messenger RNA can be retranslated unless it gets broken down, and the amino acid polypeptide can fold into its functional form. Okay. So at this point, you can read about, or not read, you can stop this video, watch this animation on protein synthesis. It's an excellent animation. And then come back and you should be able to, I'm sorry, oh, good Lord, answer the following questions about translation. So what are no, not just translation, protein synthesis in a nutshell. So what happens? What are the blueprints for protein synthesis? Where does transcription occur? What are the types of RNA produced? How does DNA differ from RNA? What are the modifications that you have to do to immature or pre-messenger RNA or pre-mRNA? Where does translation occur? What does each type of RNA do? Those are things that you should be able to answer, okay? And I'm going to stop here. This is a shorter video, so that's kind of nice. And then we'll get into the tissues section of this chapter. Yay. Have a wonderful day. Bye.